Hi, hello, how are you? Welcome to the chapter 1 of Fundamentals of Information Technology. In this chapter, we're going to use the book Computer Fundamentals, written by Pradeep Sinha and Priti Sinha. In this chapter, you will learn the following. First, we're going to define what is computer, and secondly, you will know what is data processing all about, and it will be followed by the discussion of the different characteristic features of computers, and fourth one, computers evolution to their present form, and it will be followed by the discussion of the computer generations, and lastly, characteristic features of each computer generation. Are you ready? Okay, let's define the word computer. The word computer comes from the word compute, which means to calculate. Calculate addition, subtraction, and other mathematical operations. Thereby, a computer is an electronic device that can perform mathematical or arithmetic operations. And take note of this, a very high speed. This device is also called a data processor. What does it mean? It can store, it can process, and retrieve data whenever needed or desired. Let's focus on the word data processing. Data processing is defined as an activity of processing data using a computer. We have the word here, data. Data is a raw material used for an input to data processing. I'll give you an example where your name, first name, your surname, your age are individually considered as data. If we are going to collect together this data, you will have an output as your personal information. In mathematics, 1 plus 2 is equals to 3. 1 is in data, and 2 is in data. If we're going to process it 1, it will become 3. So information is defined as a collection of related process data. Get it? Next, characteristics of computers. The first one is automatic. It means computer carries out a job normally without any human intervention. Once you are going to turn it on and put the tasks, what are the things to be done, then you will have an output and it will do automatically. The second one is speed. Take note of this. Computer can perform several billion simple arithmetic operations per second. And the third is accuracy. It performs every calculation with the same accuracy. But take note, in computing, there is a word garbage in, garbage out. Computer will solely depend on the instructions given by the programmers. If the instructions are wrong, then the output will be wrong. So accuracy will be depending on the instructions given by human beings. And the fourth characteristic is diligence. It is free from monotony, tiredness, and lack of concentration. So these things are the limitations of human beings. We will be tired, you will feel sleepy or dizzy. So sometimes you lack of focus. So computers are diligent. Next, versatility. It can perform a wide variety of tasks. And in computing, we have the word multiprocessing or multitasking. And sixth, memory. Computer can store huge amount of information. Take note, today we have 1 TB, 2 TB, terabyte. You have heard about gigabyte. So we will discuss later in the next chapters what are the different memory capacities of computers. And computer can recall any piece of this information whenever required. Seventh, computers have no IQ. So a computer cannot take its own decisions. There must be instructions, programs, okay? What to do and in what sequence. There must be algorithms. And lastly, computers have no feelings. They cannot make judgment based on feelings and instincts. Even artificial intelligence devices, they have no feelings. So these 8 are the characteristics of computers. Let's move to the evolution of computers. You heard about abacus. Abacus is a manual computing device designed by Chinese long time ago. So that particular device can compute mathematically. From that concept, here comes the first mechanical adding machine, happened in 1642, invented by Blaise Pascal. And in 1671, we have Baron Gottfried Wilhelm von Leibniz invented the first calculator. And in 1880, United States originated the keyboard machines. And also in that year, Hermann Hollerith came up with the concept of punch cards. Punch cards are devices to store instructions, and that would be used as an input and output device. It happened in 1970s. Then, here comes Charles Babbage. He was considered to be the father of modern digital computers. Why? Because he designed difference engine in 1822. He designed a fully automatic analytical engine in 1842 to perform basic arithmetic or mathematical functions. And his efforts established a number of fundamental principles to design any digital computer. And we have here in your slide some well-known early computers. Kindly read about it, search in the internet, what is Mark I, how it looks like. We have Anata Software computer happened in 1939 to 1942. We have the ENIAC, designed in 1943 to 1946, and EDVAC. Okay, so have a look these devices and see how huge are these devices, and you will be able to compare what happened in 1952 with the IBM 701, 1953 with the IBM 650. Now, let's proceed to the computer generations. So, we have 5 computer generations. We're going to focus on the various hardware technologies, software technologies that applied in every generation. The first generation happened in 1942 to 1955. Kindly take note of this hardware, software technologies, and the key characteristics. In that generation, there were vacuum tubes, electromagnetic relay memory, punch cards as a secondary storage devices. And then we have machine and assembly language. We have mostly for scientific applications. But what are the characteristics? Bulky in size, so huge. You will see if you're going to search in the internet how they look like. So memory will be in one room, and the processor will be as big as your room. So, but they're saying, some authors are saying that these are highly unreliable, limited commercial use and costly, difficult commercial production, and difficult to use. Second generation happened in 1955 to 1964. What happened at that time? Transistors were designed, developed, and magnetic cores memory, magnetic tapes, disks for secondary storage, and take note of the key software technologies here enumerated. High-level programming languages. One, we have batch operating system, and scientific and commercial applications. Third generation happened in 1964 to 1975, and we have here larger magnetic cores memory. We have larger capacity disks and magnetic tapes, secondary storage, and many mini computers have been designed, and of course key softwares, time sharing operating system, and we have the unbundling of software from the hardware. And here in the key characteristics, faster, smaller, more reliable, and there are scientific, commercial, and interactive online applications. Next, it is followed by the fourth generation happening between 1975 to 1989. So here we have the microprocessors, semiconductor memory, large capacity hard disks, and we have built-in secondary storage, magnetic tapes, floppy disk drive, and take note of the different types of operating systems. We have Unix, C, and C++ programming language, and network-based. I'm just highlighting here object-oriented designs and programming. So we have upgraded version of the fourth generation, the last. We have the fifth. It happened in 1989 up to the present. So we have here the key hardware technologies. Have a look, highlight this one. We have powerful servers, supercomputers, we have internets, we have cluster computing, and look at the key software technologies. We have the World Wide Web, multimedia, internet applications, microkernel, Java. You will encounter MPI. And they're saying this is portable. These are portable computers, powerful, cheaper, reliable, and easier to use desktop machines. Okay? And they're going to produce easily for commercial purposes, general purposes machines. So these are the electronic devices evolved. First, we have vacuum tube, we have transistor, and we have the IC chip, or the integrated circuit chip. I have here a list of words you're going to define, have a summary notes, write the definitions in 2 to 3 sentences, search in the internet. This will be your assignments, kindly defined. And lastly, I have here 1 minute to write as your reflection. Try to answer the questions in 2 to 3 sentences. What are the salient or important thoughts you have learned in our discussion? How do you feel about them? What are the things that are not clear to you? And send your answer to my email address written in the unit information guide. That's all, and thank you. Have a nice day.